in addition to all those, obviously, guys, I'm posting these examples, right? I think last class we did like 6 examples, 7 examples. But if you understand the geometry aspect of it, but you're confused about the algebra in regards to simplifying radicals, we will simplify all the radicals in these problems. So these are additional things you can go back and watch and say, okay, how did he do that in class? To maybe gain, even though you understand the geometry all right, it might be beneficial to watch these for the algebra. I'm going to, whenever we do one of these in class today, I'm going to do this. I'm going to look at that segment, and that one. I'm going to highlight all 3 altitudes, 2 of which are legs, okay? And they all, if you want to think about them as like starting at a vertex, do they all start at the right angle? So highlight the 3 segments that start at the right angle. And each one of those has a proportion attached to it. Each one of those is being able to be written as the geometric mean between other things, right? Okay. Now, if I look at those, and this is going to be critical for your homework tonight, because in your homework, I'm going to give you a picture that has every segment up there has values on it. Okay. Obviously, I think here everybody knew that we probably should start with the green one, right? Okay. But in your homework, this one will have something stuck to it. This one will have something stuck to it. But if that happens, you'll start with a proportion that you can address with the yellow. You'll then move to the green one, and then move to the purple one, creating essentially 3 different proportions. These ones in the assignment, for the most part, were individual proportions, just addressing one of the 3 geometric means. So if I look at that, x is the altitude. Okay, so that's the geometric mean, so that goes there and there, right? Now between 64 and 4. Okay. Cross multiply, you get x squared is equal to 64 times 4, right? Okay. Now I look at that, and what kind of number is 64? It's a perfect square, right? It is even. What kind of number is 4? Perfect square. Okay. So when I take the square, because I know that, because I have 2 perfect squares, and even if I just had 1 perfect square, or if I saw numbers that weren't perfect squares, but I knew there was a perfect square inside them. So say I saw like a 72 up there. Well, I know 36 is inside there. Okay. I'm not going to multiply these together. I'm going to do the implied multiplication. But I know, and so do you, that the next step to solve for x is to do this, right? Okay. So that will give me x. But now when I put this radical over here, like that, on the right-hand side, and it all has to do, guys, with our rules of exponents, or our laws of exponents. But we can take that radical 64 times 4 and write it as radical 64 times radical 4. Okay, now what's nice about that, what is the square root of 64? 8. And what's the square root of 4? 2. So 8 times 2 is 16. That's a lot easier than saying, okay, well, I'm going to take 64 times 4, which should be 256. Okay, so, just to double check for you, 64 times 4, 256. What I would normally do there, once I do a product, is just to see if that product is a perfect square. So square root that you will see it's a perfect square. Some people don't recognize that, and will say, okay, well, I'm going to take 256, come over to the side, and we'll take and divide it by 2. Well, if I do that, what's 256 divided by 2? 128. Then we'll take 128 divided by 2. 64. Take 64 divided by 2. 32. Divide by 2. Divide by 2. And I get that, right? That's the ugly thing that we get. But this is what you talked about last year in Algebra 1. Is this algorithm, okay, which is just a set of steps that you go through all the time, okay? So I start with a product and I factor it, and I stop at prime numbers, and I keep factoring composite numbers, and I just keep doing that until I get down to all prime numbers, right? That is going to allow you, last year you said you're going to group pairs of numbers, right? So we group those. Now, my hopes are that you guys realize why we're grouping those pairs of numbers. Understand 256 can be written as 2 times 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 2, right? Well, if I just look at these, or this pair, 2 times 2, that's 4, right? So does that make 256 a radical 4 times that, which is a radical 4, times that, which is a radical 4, times that, which is a radical 4. Does that kind of make sense to everybody? Okay. So grouping these things up, every time you circle a pair of numbers that are the same, what you're essentially doing is you're circling a perfect square that you know divides that number right there. Okay. So what is the square root of 4? 2. That's why when you guys circled these last year, your teacher probably said, bring out one of those numbers. Bring it out in front of the radical. So I bring out one for those. I bring out one for that. I bring out one for this group. And I bring one out for that group. And whatever's left over goes underneath the radical. Well, there are no prime numbers or left over that can go underneath the radical, right? So all I do is multiply all these things together. What's 2 times 2 times 2 times 2? It's 16, right? Okay. But my hopes are that you guys recognize that this will always work, but sometimes making these recognition arguments here might be a little bit easier, okay, quicker, right? Okay. So that was 11. Are there any others on the assignment you want to go over? 15? Yes.
How do you know which number is the coefficient?
The one that comes out. So when you divide by a perfect square. So that last one, the number that comes out and is no longer inside a radical is the coefficient. Okay, the number underneath is referred to as the radicand. All right, so again, looking at our three individual segments that we're really focused on is that one, and that one, right? Which one of them has an algebraic expression that we can actually address? The green one, right? So now you ask yourself, okay, if I'm looking at the green one, what kind of segment is the green one? Is it the altitude on the inside, or is it a leg? It's a leg, right? So then that leg goes here and here, okay? Those segments that are colored, they're the only things that are allowed to go in those two spots. Okay. Now it's the geometric mean, and I think legs are the ones that people struggle getting their heads wrapped around, but it's the geometric mean between the entire hypotenuse. So what would that distance be? 21 plus x, right? Add them together. Okay. Now, it's the geometric mean between the entire hypotenuse and that distance right there, which would be x, right? Okay. And what I want you guys to recognize or see here, hopefully, is think about what we're really comparing here. What are we doing? If I were to take the overall triangle, right? Hold on. Take the overall triangle, okay? And think about the parts that we highlighted. The parts that we end up highlighting end up being that triangle there. Okay? Remember what we did. We said this leg here, that leg is the geometric mean. So that leg right there is that one and that one, right? Does that make sense to everybody? Okay. And then when we highlighted this here, understand that that is that one, right? Okay, and then we came back and highlighted that one, right? Which isn't that one? Okay, so those are the parts that we're using, okay? And the x plus 10 and the x plus 10, they go in those spots because there's your right angle there. And here's your right angle here, okay? And when I'm comparing things, think about what we did here. So this was x plus 10, and this was x plus 21, and this was x plus 10, right? Shouldn't the hypotenuse compare to the hypotenuse? And isn't that what we have right there? Does that make sense to everybody? And then we got essentially the x plus 10 should compare to the x here, because those are then the remaining legs that we have information about. Okay. So as we go through that and we read that corollary, that's really what we're viewing. We're viewing two triangles that are similar, so we should have some relationships that we can set up proportions with. So now if I cross multiply, it looks kind of nasty initially. I get x squared plus 21x, right? And then if I FOIL this, I get x squared plus 20x plus 100, right? But what's nice about this, what happens with the x squareds? They cancel out. Move my 20x over, I get x to be 100, right? So 100 goes there. This becomes 110. Now think about this. If I have x plus 21 right there, so that'd be 121. X plus 10 would be 110. 110. And this would be 100, right? If I have the right value, if I've done everything right, and my proportion, somebody shows me that my algebra is right, but shouldn't 121 times 100 give me the same thing that 110 times 110 gives me? And we do see that those cross products are equal, so that means this, for the proportion that we set up, for that proportion, we've done the right algebra. Does that make sense to everybody? It doesn't tell me that the proportion is right for the picture. It doesn't tell me I did my geometry right. It tells me I only did my algebra right. Okay? Let's do some of these and actually get some radicals to kind of appear that we have to simplify. Is this 12? We can do.
Yeah.
Okay, cool. All right, so this one, and this is what I want you guys to recognize, because x and y are now both incorporated here, right? Do not ever, throughout the rest of your math career, ever say, well, x is alphabetical, so I got to solve for that first. Okay? You might, in your homework tonight, I know it's going to happen, you might create two proportions that you can't solve either of them right away. It's not until the third one you can really solve it. So my suggestion to you guys is highlight, whether you do it visually or you actually take a highlighter or crayon or whatever, and say, I'm going to focus on that segment, I'm going to focus on that segment, and I'm going to focus on that segment. And I'm going to write the three proportions that are associated with those respective segments. Okay? Now, obviously, this blue one doesn't have anything stuck to it, right? There's no expression here. So I'm really only going to have to deal with two right here in this question. But let's look at the yellow one. The yellow one is a leg, right? So I can go here, and it can go there. Now, it's the geometric, remember, a leg is a geometric mean between the hypotenuse. What is the hypotenuse here? 15. And now what is the part of the hypotenuse that's touching that leg? 8. Okay. So that's one proportion that allows us to solve for y. I'm going to go to the green one now. And that is the altitude, right? That's the interior altitude. So it should be the geometric mean between what things? Remember this picture when we highlighted those parts? 8 and 7, right? So when I cross multiply, then I should be able to solve for x. Okay, so we come down here a little bit, and if I cross multiply, let's just solve for y here. I get y squared. A couple ways you can do this. Anybody know what 15 times 8 is off the top of their head? 120. Okay. So you can do it this way. So okay, now I'm going to take square root of 120. And then maybe you go to the side and say, okay, 120. And this is, guys, this is what I suggest if you're not, some people are saying, this takes way too much time for me. I'm not going to do it this way. Okay? Which is fine. That's great. Some of you are going to have to do it this way. Some of you have to say 120. 2 goes into it. Gives me 60. 2 goes into 60. Gives me 30. 2 goes into 30. Gives me 15. 15 gives me 3 and 5. Absolutely nothing wrong with that. Then you say, okay, I'm going to group up 2. Now, does the 2, the 3, and the 5, can they be grouped up with anything? No. So this 2, this product of 2's is actually square root of 4, right? So that's going to come out as a 2. And now what happens to the 2, the 3, and the 5 there? They all times each other and go back underneath the radical. So it gives you, what, 30? So 2 radical 30. Okay. Some people are going to do that. They're going to say, okay, I see that 120. I'm going to divide it by 4 and 30. And then they see 30 and say, okay, we've talked about this in the past. We know that really, when we're doing this, we really mean that. Okay, sometimes we leave those out because it's just a lot to write. But radical 4, he's saying radical 4 times radical 30. And he said, okay, well, I know radical 4 is the perfect square, so we'll stop there. But radical 30, if that's going to have a perfect square inside it, that perfect square has to be less than 15, doesn't it? So then I think, okay, does that divide by 4 evenly? It doesn't. Does it divide by 9 evenly? And it doesn't. Okay? Those are the only 2 perfect squares that are potential for dividing 30, right? So 30 is already simplified. So then you say, okay, well, radical 4 became 2. And I'm left with my 30. Okay? Some of you might even do this, like a y squared, where we have 15 and 8. Do it this way. Square root both those, you get radical 15 and radical 8. Well, radical 15, for the same reason, doesn't have a perfect square that will divide it, right? Just like 30 didn't. Half of 15 is 7.5, right? The only perfect square less than 7.5 is 4. 4 doesn't divide 15 even, so that's simplified. Now 8, though, is there a perfect square that divides 8? Yeah, 4, correct? So 8 really goes down to radical 4, radical 2, but radical 4 is just 2, correct? And you still have this radical 15 here. Does anybody know how to multiply radicals? Remember from last year? Say again? Okay, you're going to multiply. Now these numbers on the inside, these are called radicands, spelled R-A-D-I-C-A-N-D. Okay? You're going to multiply the radicands together. So it's 15 times 2. 30. And wherever they start is where they finish. So they started on the inside, they're going to finish on the inside. Then you multiply the coefficients. What are the coefficients out here? What's this coefficient right here? 1. Okay, so what's 1 times 2? 2. Okay. Would you guys agree that we've seen varying ways of thinking about solving and simplifying radicals? They're all related. They're all the same idea, but you can kind of interchange maybe steps that you conduct on them to make the processes maybe look a little bit different. But the overall thing, every process we ever go through is targeting the idea that we're trying to divide out the largest perfect square that resides inside the radicator, okay, as a factor. So doing x then, so what we've got, let me just clean this up a little bit. For say, I'm going to go x squared is equal to 8 times 7. X then is equal to the square root of 8 times square root of 7. What's square root of 8? This becomes something that you guys should, if I say what's 2 divided by 4, you automatically tell me 1/2, right? You've seen it so much. Square root of 8 is 2 radical 2. It's going to be something that you see so often, okay? And now you have that radical 7, right? So what's 2 times 7? 14. That should go underneath the radical. 2 times my 1 is just 2. Okay? Some of you might have said, well, I'm just going to do 8 times 7. What's 8 times 7? 56. You know 56 was made by 8 and 7, right? 4 and 2, and then 2 and 2, right? Is that a pair of 2s? And that's where that 2 came from. Is 2 and 7 14 together? And that's where the 14 came together. It came from. Varying ways to do it, guys, and I want to try to give the varying levels of understanding options, okay? If you're a person that has very, 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 very limited understanding, that factor tree is going to get you the answer every single time. If you're a person that has a high level of understanding, maybe some of those alternative methods are going to maybe save you a little bit of time. Are there any others on here you guys want to talk about? Any? The last class had some other. They wanted to talk about 13. I think it was. Did you guys do okay with this one? Yes, yes. Let me, because we're having a little bit of time here, let me work with you individually on that. Is there anything 1 through 7, any concept, ideas, problems that you guys are struggling with that you're not confident in? I'll stop there then with the